Hey guys, today we are looking at part one of 12.5. We're doing pyramids and cones. Today we're just going to focus on the pyramids, and then part two will be the cones. Just another reminder about volume. Always good to recognize that volume measures what is on the inside of one of these shapes, whereas surface area was everything that measured the outside of the shape. So if we look at the volume of a pyramid, so this is going to be our focus today, you'll notice that it's, again, almost identical to the prism formula. It's simply 1/3 area of the base times the height. If you want, as we've done with previous formulas, instead of saying 1/3 area of the base times height, if you want to write it as this, I do think that can help people sort of calculate this maybe a little easier. So not a whole lot new to this. We're going to find the area of the base. We're going to multiply it by the vertical height, and then we'll just divide it by 3 since it's a pyramid instead of a prism. Okay, super important part of this. When we do the area of the base times the height, it's extremely important to make sure that we use the vertical height because that is what's perpendicular to the base. And that's super important. When we did pyramids in surface area, we dealt with a slant height that looked like this, simply because when you do surface area, you're measuring what's on the outside. And so if the outside is slanted, then you would use the slant height. But with volume, that's not the case, right? Volume, we measure what's on the inside of the shape. And so it's really important that we use a vertical height when we're doing volume. You will see some things like, don't forget that if you take this and draw it straight over to the slant height, it does create a right triangle. And so there could be times where you have to use a little Pythagorean theorem or something like that in order to solve for something. But we do always get that kind of right triangle when we connect the vertical height to the slant height. But again, do keep in mind that this is the vertical height that we're using today. So let's jump over to our 4 problems that we're going to do together. So as with all the others, I always encourage you guys to just map out the formula. So area of the base times the height divided by 3, and then show what you are subbing in for those values. So I got the area of the base right there, the vertical height right there, and then we're going to divide by 3. So let me start with the area of the base. So our base is a rectangle. It's 12 by 8. And so we're simply going to multiply 12 times 8 to get the area of the base. Our vertical height, as you can see right here, is 10. Which looks like this. So you could type that into a calculator. Let's see, 320, I believe. If I just did that correctly in my head. I was just thinking of this as 3 goes into 12 4 times. 4 times 8 is 32. Times 10 would be 320. So that should be right, but you can always check that in a calculator just to make sure it's correct. But that's it. Let's do a few more of these guys together. I wanted to give you some practice with the different, sorry, I'm just trying to adjust to get it correctly on the screen, with some different bases. So this is obviously with a base of a rectangle. We're going to look at some bases with triangles and then bases with a regular polygon as well. So just to give you a few different looks, so do make sure you go through all these, fill these notes in with me. So we're going to do the same thing on this. We're going to say our volume is area of the base times the height. Now in this case, our base is a triangle. And so right here in my first set of parentheses, I am finding the area of this triangle. And then we will multiply times the vertical height. Let's just note that now because that's the easiest one to find. So let's just start with that. We can see that our vertical height is 15. So let's just put that in for height. And as far as the area of the base goes, because it's a triangle, I know that I'm doing 1/2 base times height. So remember, whenever you're doing a triangle and you're considering base and height, your base and your height have to be perpendicular to each other, which is why I need to use this leg and this leg as my base and my height. Doesn't matter which one's which, but those are the two I need to use because they are perpendicular to each other. Can't use him this is just our hypotenuse. We're going to use this to help us find something right here that's missing though. So as far as the area of this triangle, 1/2 base times height, so 1/2, let's call 6 our base. And if this is my base, then this would have to be my height. So in this case, I would have to use a little Pythagorean theorem to figure out what this is. So I could do something like 6 squared plus b squared equals c squared and solve for this value. And if you did that, you'd find out that it's 8 with a little Pythagorean theorem. And so we now have the setup for the volume of this pyramid. At the end of it all, we will divide it by 3. So it's going to look something like this. You can do that in your calculator. I think we could actually just do this one in our head. 3 goes into 15 5 times. And 5 times 8 is 40. Half of 6 is 3, so 40 times 3 would be 120. But you're welcome to do that in a calculator and make sure we're getting that right. On a test or a quiz, I would always want you guys to not take risk and be safe, put it in the calculator, make sure your answer's right. Okay, let me jump down to these guys. So pretty similar process on these, although this triangle is just a little different, so I wanted to try to give you a different look. Let's just do our usual layout here. Area of the base times height over 3. Let's see what we got. So in this one, as far as that triangle goes, I can see that this would be the height of that triangle. What I don't know is the base of that triangle, which would be right here. So let me just kind of lay this out, and we're going to find the parts and plug them in as we find them. So for the triangular base, it's 1/2 times base times height. And then the height of the pyramid, all divided by 3. Let's see, did they tell us any of those things? We do know that as far as, let's just start with the base. I'm going to start with him. So as far as the base of our pyramid, which is this triangle, we do have a height on that triangle is 4. But we need to come up with this piece right here. So I'm going to separate out that triangle because I want you guys to see this a little more clear. So they told us that these two were congruent. These are both 8. So I'm going to put those here. They told us this height is 4. So I'm going to put that here. And we just need to come up with this. Now that I lay it out like this, it looks pretty clear. We got to use a little Pythagorean theorem in order to come up with this guy right here. So if I did a little 4 squared plus b squared equals 8 squared, let's see what that would be. So about 6.9. Let's call it 6.93 just to be safe. So that's him by using a Pythagorean theorem. And we really need the whole thing, so I need to double that in order to get the entire base. So 13.86 would be the whole thing. Right, so the entire length is 13.86. All right, and we've identified the area of our base, which is just the area of this triangle. We did 1/2 the base times the height, and the height of the pyramid. They're not really giving us, so we're gonna have to solve for that too. Let me show you kind of what I'm seeing here. They're giving us this edge. This is what we would call a slant edge, is 12. Based on what I see here, I know that this would also be 12. But what we need is from here straight down that face to the bottom middle. So this is really what we need. That would be the vertical height of this pyramid. This is a tough one to see. Some of these 3D shapes can be a little tough to kind of visualize what you're finding. But because this wall, this triangular, is perpendicular to my base, I know that this can be my vertical height. So we got to come up with that value right there. So how do we do that? So it looks like on this, I'm going to take this triangle, if you guys can see this one right here. So this is 12, this is 12, and then I'm going to bring over that dotted line. So I got the 12, and this was that dotted line. I'm just going to separate out that triangle so you guys can see what we're working with. So this blue line that I drew down the middle is what we need. This would be the vertical height of this pyramid. And so that's what I'm solving for in order to get this guy, to finish off our formula. So what do we know so far? We do know that from here to here, as we just discovered, is 6.93. And now we can do a little Pythagorean theorem here in order to get the vertical height of our pyramid. Okay, and so I'm going to do a squared plus b squared equals c squared in order to get this guy. So let me jump you to that calculation. So I'm looking at 12 squared minus 6.93 squared. So a little Pythagorean theorem, and we got our vertical height, 9.7, I guess we should call that 9.8, since these guys all round up. All right, so that was this, which was this, which is our vertical height of that pyramid. That was a tricky one. That's about as hard as they get. So let's take this and just multiply all this out. So I'm going to take my 9.8 times 13.86 times 4 times a half and divide all of that by 3. And that should be our volume. So 90.5. Tough one. Okay, let's jump over to this. With this one, still doing the same process. The base is challenging because it's a hexagon, but we can do it. So let me put it down here. So I'm going to do, still looking for area of the base times the height. In this case, because our base is a hexagon, remember our formula for the area of a hexagon is 1/2 AP. So 1/2 times the apothem times the perimeter. The perimeter on this will be really easy to find. The sides are 6. So I have 6 of those. So if I did 6 times 6, I get the perimeter, which is 36. I just need the apothem, right? Remember, the apothem is this right here. That's our apothem. So like what I did in an earlier chapter, I'm going to separate out this hexagon, at least part of it. All right, here's kind of the bottom half. So 6 by 6 by 6, that's this guy. So these guys are all 6. So naturally, when you do draw in the apothem, it does cut your base in half. So these guys become 3s. So it looks like this. With a hexagon, as we saw in an earlier chapter, this is a 30, 60, 90 triangle right there. And if this is our short leg, we can get the long leg by multiplying by the square root of 3. So there's our apothem. Apothem is 3 radical 3. And we have the vertical height, which they're telling me is 18. So that's going in for my vertical height. I can't forget to divide this by 3. I didn't write it here, but I'm remembering that now. So this is what our complete setup would look like. So this is 1/2 AP, right? This was the perimeter, this was the apothem, times the vertical height, divided by 3. I'm going to do all that in my calculator to finish this one off. So 1/2 times 36 times 3 radical 3 times 18. And I'm going to divide all that by 3. So 561.2 should be my volume. So guys, again, a lot going on with some of these. It's easy to miss one number and kill the answer. So just make sure you're laying everything out nice and clear, just like we did on this one, just to make sure we're getting that answer correct. But that's it for part 1 of 12.5.